This video reviews how to remove all of the pivot tables on an Excel worksheet by using the Python library OpenPyXL. Here is our testing document, which has a table of data in the first three columns. Column A has the year, column B has the month, and C contains a list of random numbers that increase over the years. To the right of this data are three pivot tables. The first is the average amount by year. The second is the sum of amount by year, and the third is a comparison of the sum of amounts between 2021 and 2024. You can see in all instances that the numbers are increasing gradually over time. Let's use some Python to remove all three pivot tables from the sheet. Here I bring in the workbook as WB, and I select the worksheet as WS. I will then be saving the work in the cell below. I start off by checking out the pivot tables we have available on our workbook currently. I do this by accessing the _pivots attribute of the worksheet object. This attribute contains all of the information regarding our pivot tables, including things like where they are, what the pivot tables are displaying, and a whole other assortment of other information, all of which you can see is contained in this very verbose output of XML. We don't need to look through all of this though right now, so I'm actually going to truncate this output by putting a semicolon and executing the cell again. Just to validate that we have everything within this attribute, I want to run the len function and pass it the _pivots attribute. 3 is output, which is correct and expected given that we only have 3 pivot tables. The actual removal of the pivot table formatting is very easy to do. Since the pivots attribute is just a list of pivot table objects, you can remove them all by assigning the attribute an empty list. Let's run this, and then I will rerun the pivots attribute cell above, and see we have nothing there anymore. I will now save the workbook as test no pivots, and check out what we have. Well, this isn't quite right. The pivot table formatting is gone, but the content of the tables are all still there. No matter though, we can use some logic in Python to help with this. I will restart by importing our original notebook with the pivot tables formatted as we saw it at the beginning of this video. I will also rerun the len function here to make sure that we have our 3 pivots. We do indeed as we get 3 output. What I next need to do is, before I go about removing those tables, I need to collect where they are on the sheet. That can be done with this block of code. Let me walk through what is going on. First, I instantiate an empty list and store it in the pivot table locations variable. I next create a for loop to iterate through the amount of pivot tables that we currently have. I use the len function, which we know will produce 3, and pass that to the range function to create my for loop. Each loop variable is called PT, which, when looping, will be 1, 2, and 3. Within the loop, I want you to focus only on this portion of the code. This is how I will collect the location of the pivot table. Each of the pivot table objects within my pivots attribute has a location attribute, which, on top of it, has a ref attribute. That ref attribute contains 2 cell locations, the top left cell and the bottom right cell of the pivot tables. These are the bounds of our pivot tables. I use this print statement here to print out that location for visual confirmation below once the cell is executed. I assign that location to the this PT location variable, and then I add that location to the pivot tables location list object that I created at the start of this block of code. Finally, in the last step, I remove all of the pivot tables. Executed, you can see where my pivot tables are: H2 to I7, E2 to F7, and E10 to H24. Let's clear those locations right now of all of their cell contents. Now, there is a lot happening here, but I'll walk through it bit by bit. I start off by importing the column index from string and the get column letter functions from the utils module of OpenPyXL. I also import the regular expression library with RE. More on these three soon. Below, I begin a for loop that iterates through the list of pivot table locations we just created, so this loop will go 3 times. The first line within the loop extracts the start and end locations of the pivot table by splitting the string on the colon. On the right, you'll see I have commented out what the variables will contain for the first loop of the 3 for loops. The variables pivot table start and pivot table end will contain H2 and I7 respectively. You will also see some other comments within this for loop. These are all of the values that will be captured in the variables for just that first for loop. With the pivot table start and pivot table end variables created, I now need to collect the column and row of each one. I have these location variables declared here, one for start and the other for end, and they are being assigned a regular expression match object. I have the search function of the regular expression finding the first instance of a number within the string of the pivot table start and end variables. The reason I have to do something like this is because I don't always know how many letters or numbers I will have in my column and row values. I can't simply pull the string apart with indexing because, as you can see in this case, sometimes my numbers are in the single digits, sometimes they are in the double digits, and they can certainly be more. The next 4 lines of code do pretty much the exact same thing for each of these 4 variables: column start, column end, row end. For the column ones, I collect from the pivot table start or end variable the location up to where the number starts. This will leave me with the column letter. For the row ones, I collect everything after where that number is, producing only the number of the row start or end. Since these return strings, I need to use the int function to convert the string to an integer for the rows. Now let's talk about this for loop. I start by iterating through a range of rows where our pivot table starts and where it ends. Next, I go through the columns. Here is where I need to use our column index from string function. This gives us the number location from the letter that we pass it. In order for me to iterate through the columns I want to change, I have to cycle through the correct range. The range function only accepts numbers, so the way that I address this is by passing the letters we retrieved from the pivot table's location to the column index from string function. Here you can see that I use the function twice for the 2 range arguments. I should mention here that both of my range arguments add 1 to that second argument number because the second number is not captured within the range. Adding 1 will ensure that I'm covering the entire pivot table. The action taken in this loop is to access a specific location in the cell and assign its value attribute none. I collect the location I need by converting the column back to a letter with the getColumnLetter function and passing it the column number for that loop. After that, I add the row of this given loop. Accessing the cell is that easy. So let's execute this, save the document, and see if we no longer have any pivot tables at all. There we go. Blank, unformatted cells where the pivot tables used to reside on our page. So to get the pivot tables off of your workbook completely, you are required to do a little bit more than just removing the pivot table objects. You must first collect where those tables are, then remove the formatting from the sheet, then follow that up by assigning all cells within the bounds of those tables the value none. Thank you for stopping by and checking out this video. Please do give the video a thumbs up if you found it to be helpful, as that does help others find this content. Leave a comment below letting me know what other features of OpenPyXL, Python, or Excel in general you'd like to see reviewed in future videos. And don't forget to hit subscribe so that you know when the next video drops.